us in connection to Science Night. Please stand by.
Welcome back to another edition of the Science Night podcast. My name is James, and with me, as always, is Steffi.
Hey.
And Jason.
Hello.
We also have a special guest appearing for the fifth time. It is everyone's friend, Bill Sullivan.
Hello, everybody. Do I have to say hello 5 times?
We'll stitch it retroactively back into the times when you forgot to say hello.
Well, I'm glad you guys are gluttons for punishment and keep inviting me back. It's great to be here once again.
Certain topics just kind of scream for you to be coming onto our show so that everyone can have disturbing nightmares going forward.
Like I said, it's always an honor.
Yeah.
You know, when I get a call because, hey, there's something gross on TV and I thought of you.
Yeah.
Tonight, we're talking about a bit of the science of The Last of Us and a newly discovered substance that could save us all. Bill, you've been on a lot of times, so we know a little bit about you, but things change, new things are happening. I saw, I guess, congratulations in order that you're no longer the interim chair. You've passed that torch on to the next person who has the honor of serving in that position. So how are things post-chair?
Well, I hope you're right about that, James, because I have been interim chair of Pharm and Tox at the IU School of Medicine for some time now, and they tell me that my replacement starts on April 1st. So I'm not sure if they're joking or not.
Oh, no.
Assuming that this is not an April Fool's joke, my time as interim chair will end April 1st, which is also kind of fun because April 2nd is my birthday. So the new incoming chair is kind of automatically giving me a birthday present by saying, you don't need to worry about this stuff anymore. I got it. So that kind of worked out nicely.
And why don't we refresh everyone's memory? Why don't you tell us a little bit about what it is you study and research?
Yeah, so I've been at the Indiana University School of Medicine for 23 years now, and I've been investigating parasites, primarily one called Toxoplasma gondii, which I've talked about on the show before. It is often called a zombie parasite, and we can review that again if you want, especially in the context of The Last of Us. But my lab's been dedicated to trying to understand how that parasite, which infects billions of people, stays in their brain as a latent cyst for the rest of their lives. And we're trying to design new medicines to eliminate this infection, especially from vulnerable populations like the immune compromised, in which case Toxoplasma can be a life-threatening pathogen.
Why that parasite? Why did you choose that for the focus of your lab?
That goes back to my graduate school days, because that's when I was introduced to the parasite. I went to graduate school in the 90s, so this was some time ago, and HIV/AIDS was still kind of at its peak. And many people infected with HIV developed AIDS and were developing toxoplasmosis as a cause of death. So there was a huge push to start to understand this, up till then, rather obscure parasite. So we kind of caught that wave of implementing and developing a bunch of tools that would allow us to dissect Toxoplasma gondii in an effort to develop better and safer treatments for AIDS and other immunocompromised patients. And I've been riding that investigative wave ever since. It's a fascinating parasite, not only because it's a pathogen of humans and livestock as well, but there's been emerging studies in the past couple decades suggesting that even if this parasite is present in the brain and not causing overt symptoms of illness, it still could be causing neurological problems. And this is best demonstrated in mouse models, where if you take a chronically infected mouse that doesn't look sick at all, it's behaving a lot differently than an uninfected mouse. And one of the most striking findings is it loses its fear response. It's no longer even afraid of cats. And this is where it gets really evolutionarily interesting, because the cat is the definitive host of the Toxoplasma parasite, which means it's the only host on Earth where the parasite can complete the sexual stage of its life cycle. So it really doesn't want to get into people or goats or rats. It wants to get into a cat. That's where it can have sex. So if it finds itself in a rodent, the best it can do is rewire its brain in some way to get it to lose its fear of cats. And then that infected rodent will be more readily preyed upon by the cat, and the parasite gets into the cat's belly where it really wants to be. So pretty clever move on behalf of this little single-celled parasite.
When you said you were introduced to this parasite, I thought for sure it was like at backstage at a Ted Nugent concert. Hey,
Jason, you should know I would never, ever be found backstage at a Ted Nugent concert. And in case your mind was going to cat scratch fever, toxoplasma doesn't cause that. That's a completely different ailment, and it's caused by a bacterial infection. Some people think cat scratch fever relates to toxoplasma, and there's no relationship at all.
I feel like every time you're on and we talk about this, I have to throw that out there so that way you can correct me and correct everyone else who thinks that it might be the same thing. It's my sacrificial question for you.
It's that time of year when an HBO prestige series captures the imagination of the world. This year we have less dragons, but more Pedro Pascal, so I think that is a very even trade. Of course, we're talking about The Last of Us, the series based on the 2013 game produced by Naughty Dog Studios, which set a new standard for storytelling in video games. It's set in a post-apocalyptic world where a species of cordyceps fungus threatens the existence of humanity. And we know there's a lot of articles and podcasts and videos recently talking about this cordyceps fungus and whether or not the zombie apocalypse is just around the corner. But those people don't have the dulcet tones of Bill Sullivan to tell you that this is a fake fungus and could never create a zombie ever anywhere in the natural world. Bill, tell me about how I'm totally right and we don't have to worry about anything.
All of your listeners should know that you're always right, James.
I'm just going to clip that out, put it on my wife's phone.
That'll last 10 seconds on her phone.
I'll be sued for false advertising.
Sure.
So yeah, you're largely right. Cordyceps in the game and in the show is based on a real live fungus that is out there in the world, perhaps better known as the zombie ant fungus. So it is based on a real pathogen, but it doesn't infect humans, and by any stretch of the imagination, never could in a short amount of time. It would take millions and millions of years of evolution for such a thing to happen. And based on what we know about fungus biology in general already, it just doesn't seem to be a really plausible thing to happen. But what is interesting is that the writers very astutely adapt what cordyceps does in ants and changes it would have in human behavior. Now, of course, there's a lot of dramatic license taken with the biology behind cordyceps and how it changes the behavior of ants, but we wouldn't be on the edge of our seat if the writers didn't do that.
So if there are people out here who either played the video game or maybe only played the video game, there is a little bit of a difference in how cordyceps is passed from host to host in the show. So in the video game, famously, it is based on spores. So there's a lot of times where you gotta like hit the button that throws your gas mask on. The creators of the show switched to a tendril-based system of passing it on, mostly so they could not have Pedro Pascal in a mask. There's already a show about that on Disney Plus, and they don't want to get sued. They kind of switched up the mode of transmission. Does that like totally fall outside the realm of possibility on how a fungus could infect another host, or is that still a possibility maybe with something else?
I haven't seen the game, so you'll have to get me up to speed on that. But what I've seen from the show is that this seems to be transmitted primarily by a bite. People who are infected with this fungus start to exhibit characteristics that we would mostly associate with rabies, which is a virus, not a fungus. But the rabies virus also plays tricks on the brain, and it concentrates in saliva. The behavioral changes that we see with rabies cause people to become more aggressive. They end up biting. And that's how the virus in saliva gets into the bloodstream of the new host. And that seems to be what's kind of been mimicked in Last of Us. You bring up a really good point. The major way fungus get around is through spores. They're carried on the wind and in the dust. People or animals breathe them in, and that can get them started as an infection. There's a whole variety of fungi that don't even go into us internally. They're called the dermaphytes, and they infect skin. So all they need really is a rather warm and moist environment, like in between your toes or something like that, in order to set up shop. So one of the major problems right at the get-go with a fungus invading a person to have a serious illness is that we're too warm. A lot of fungal species don't inhabit us because of the body temperature. Fungus prefer to grow on dead things. You walk through the forest, you see fungus everywhere, usually on decaying matter, because one, the temperature, and two, it's not alive. The other thing that we have going for us is a really strong immune system, and that keeps most fungal pathogens at bay. The majority of cases that you would perhaps see in the clinic are people who are immune compromised for one reason or the other, or maybe genetically predisposed to a fungal infection due to a weakened immune response, or the cases where there's basically hygienic issues and the dermaphytes can take root. Those are a couple things that cordyceps would have to face. One, we're too warm. Two, we're too alive. And the third thing is that we have a slew of antifungal medications that are not even mentioned in this program, to the best of my knowledge. It would be hard to believe that every single one of them would have failed to have any activity against cordyceps.
How cold are ants? Because you said this infects ants.
Oh, yeah. So not all fungi are created equal. Some they survive in different environments. There's even some that thrive in the desert, in the dry desert. So we don't mean to generalize all fungi are behaving that way. That's just how most of them respond. So they can live in very different environments. And the ants in particular are pretty interesting because the fungal spores of the zombie ant fungus land on an ant while it's on the ground, okay, which is usually the forest floor. It's usually a little damp, maybe cooler than, as you go up in the air. So when zombie fungus hits that ant, it starts to take root and slowly grows. That's another difference between the real zombie ant fungus and what we see in the show. The speed at which this infection takes place, it's lightning fast on the television show, which is good because, in my opinion, the plot moves pretty damn slow as it is. We don't have time to wait around for fungus to grow.
Constructive feedback to HBO.
Sorry, I'm getting old and I get impatient. In the real world, this zombie ant fungus, it takes a little while to grow before it slowly consumes the ant. And it does so kind of piece by piece. It doesn't go straight to the brain. So it starts to take over the muscles first, and then it starts to interfere with the chemical signals that ants use to talk to one another and to orient themselves to their position in the colony or in the marching line that we usually visualize when we think about ants. Ants are blind, just to remind you guys, they can't see. So they are utterly reliant on these chemical signals that one another is releasing. So this zombie ant fungus starts to interfere with the way those chemicals work in the infected ants. So they really can't tell where they are anymore. So they tend to wander off from the colony, which is very unusual behavior. And some of them probably randomly go up trees or shrubbery. Then the zombie ant fungus can sense that change in temperature. There's a gradient in temperature that's different from like the forest floor to when you're, up on top of a shrub or something. And then the fungus starts to invade the brain, not the brain cells per se, but, the brain organ itself, probably by interfering with neurotransmitters like serotonin and dopamine. that's how it can start to change the ant's behavior. And the key behavioral change is that the ant will latch on to the underside of a leaf and just kind of freeze and just stay put. So that could be neurochemistry at work, or it could be the fungus has grown throughout the ant to such a great extent that the ant just can't use its muscles anymore. They've either been destroyed or atrophied, and the ant can't move because it literally can't move. Its muscles are shot. Researchers are still investigating the mechanism of how exactly that happens. But the key thing that happens at the end here is that the zombie ant fungus continues to grow, consumes the ant, and then a stalk just ruptures the ant's head and starts growing out of it. Now that sounds really gruesome, but the ant's probably been long dead since then. And from this stalk, fungal spores are released, and thanks to gravity, they fall to the forest floor where all of his ant buddies are located, and then the infection cycle continues. So that's how the zombie ant fungus works. And you can see now, for those who have watched the show, there's some similarities, but also some differences in how the writers, adapted something that we see in nature to a really exciting fictional account of this infection jumping to humans.
So ants turn into clickers.
Ants turn into clickers, yeah.
Exactly. So, Bill, you mentioned, the idea that humans are too warm for most fungi to be able to survive, but that's not always the case. And the premise of The Last of Us is that climate change has actually led to adaptations here in the fungus. This is reminiscent of what we see going on now with valley fever, which is an infection in the lungs that happens in desert areas primarily, but potentially because of climate change, it is now occurring more widespread and causes a severe lung infection. Does that science seem to track well with sort of what you see in The Last of Us, or is it totally off the mark? I'm not a climate change person. I know you're not a climate change scientist either. However, you are a parasite scientist, and I'm wondering what kinds of adaptations you can see in either viral or fungal species might make them easier to infect a host or occur in a more widespread geographic area.
Yeah, there's actually two angles to that. That does track very accurately with what we're seeing with respect to infectious diseases and global warming. So a lot of the vectors for these pathogens were not able to survive in colder environments. They are usually located in the tropics or subtropical regions. But now we're seeing, just for example, and this goes well beyond fungal organisms, for parasites, for example, as the planet warms and we're seeing average temperatures increase with every year, we're seeing a migration of the bugs, the kissing bugs that carry a parasite that causes Chagas disease. It was extremely rare in the past to ever see Chagas disease in the United States, but now it's becoming more and more common because the southern United States is now hospitable towards these kissing bugs which carry the parasite. So we're seeing outbreaks in Florida and Texas and some of the other southern states that have never reported Chagas disease before, and that is directly linked to global warming. The other one that I've written about a couple times is the brain-eating amoeba. This is another parasite that pretty much does exactly what the title suggests. And it's really been localized to the southern region of the United States historically, since it was first reported back in the 50s or 60s. And this is a pretty rare infection. But we've seen cases in recent years as far north as Minnesota. So it's really creeping up as temperatures rise. So yeah, global warming, in addition to having all the well-known effects on the planet that people talk about, we are going to be seeing unusual patterns of infectious disease that we've never seen before because we are creating environments that are more hospitable. Now, I said there was a second component to this because as you do that and you provide more areas where these bugs can grow, two things happen. One, more people get sick Okay. And as more people get sick, these bugs are going to find those individuals who are vulnerable to the infection. So even a bug that normally doesn't infect a lot of people, it could find that subset of individuals just based on those increased numbers. And the second worry is that as more people get infected, you create an environment that is conducive for these pathogens to develop resistance to the drugs that we have. And this is a very alarming danger because there isn't a balance of research to find new antibiotics or new antifungals that keeps up with the speed of resistance that these pathogens can evolve. So global warming has the potential to create infectious disease catastrophe. Don't want to be alarmist because this would take time, but my understanding is that the climate is warming a lot faster than scientists anticipated. And we are, in fact, seeing patterns of infectious disease consistent with the theories. So, yeah, it's very worrisome.
It's absolutely mind-boggling to me, Bill, that in the shadow of a global pandemic, we're still shocked at what the potential is right out there as a result of climate change and don't really have a solution for it or even a plan of attack to address it. I just cannot even put my head around it. Thanks for keeping me up tonight.
Yeah.
Like I said, I don't mean to be alarmist. This isn't going to bother you in your lifetime, probably, but we can't shirk our responsibility onto future generations. And of course, history will not speak well of those of us who did not take action despite the overwhelming evidence that has been told to us ever since the 50s that climate change is a real disaster. We should have gotten a handle on this back then. Even if we start making changes now, some of them are already going to be irreversible.
Maybe the silver lining is that even though history may not be kind, there may not be anyone around to remember that history. So.
There you go. Always on the bright side.
The silver lining is that the cordyceps zombie plague won't happen, right? That
There you go.
You gotta find the silver lining.
The cordyceps ain't going to happen. If anything kills us, it's going to be the stupidity of other humans.
Yeah, they made that movie
Homo
too.
sapiens.
Well, let's take a quick break. We'll be right back with some more fungal facts, but first, a message from a podcast that I think you will enjoy.
Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
They make the sound by vigorously rubbing their penis on their abdomen.
Oh, yeah. Oh, my gosh. Then at night, they come out and crawl around your face and mate with each other.
Oh.
But
Sorry,
get this.
I would like to sleep tonight. As naturalists, let's face it, we find something dead, we go and we poke it with a stick. I did that with the deer like 3 weeks ago.
As you do. Rachel, no. You weren't paying attention. Blood and mucus.
Oh, right. Sorry.
All right, this episode is going off the rails.
This is the quality content
absolutely.
people come here for. Strange by Nature podcast was chosen as one of the best science podcasts of 2021. Come join the fun wherever you find your podcasts.
Welcome back. In the first half, Bill horrified all of us by telling us that cordyceps is not going to kill all of us, but we will all die from something. So that was fun. I think in the second half, we can talk more about how fungus can benefit a people by changing the economy and how people work within their environment. So we were just talking about how Ophiocordycepsis effectively zombifies its host. In this case, we're talking about ants. But let's talk about how a different species of that fungus, Cordyceps sinensis, which basically mummifies its host. So not a good thing for the host, but stay with me here. And it creates the highly sought after caterpillar fungus from the Tibetan plateau. So if you're not familiar with the political things happening on the Tibetan plateau, this is not the podcast that's going to fill you in. Let's just say that people who lived in Tibet for a really long time are not able to do the things that they historically have been able to do as far as agriculture and nomadic herding and all that fun stuff. That there's a geopolitical podcast to tell you all about that. But here's the thing, the people found this little niche of looking for caterpillar fungus, which at one point was worth more than its weight in gold because of its value in traditional Chinese medicine. So let's talk about the good fungus that we all interact with all the time. I wanted this to be a little bit of a palate cleanser. We don't necessarily have to talk about caterpillar fungus, but we all interact with fungus all the time. We don't gotta be scared of these little guys, right?
Well, every fungus is edible once.
Once.
Right?
That's right. Everything's edible if you're not a coward.
Right. I agree with you. I'm not afraid of fungus. I think there's a lot of good fungus out there, and there's a lot of good even medicinal value in fungus, right? There's a lot of research coming out now about the psychoactive effects of like psilocybin, for example, the magic mushroom, and whether or not it's helpful in treatment in microdoses for depression and things like that. It's interesting. There is value to fungus. I think there are several fungi that are used as either aphrodisiacs or as potential treatments for erectile dysfunction. Shocker, right? I think one of the stories we read for this week said if there was going to be a fungus outbreak, it was going to, that was going to kill humanity. It was going to be because some rich guy was using a fungus for some great Saturday night out. That's how it got out, which I thought was, probably pretty appropriate. But yeah, I don't think cordyceps aside, right? And the idea that ants can be zombies, I'm not scared. I'm way more scared for the other things Bill talks about than the fungus.
Another thing that, along the lines of what Jason was talking about with regard to some medicinal value located in some of these species of fungi, that's really spot on and really should, research in that area should be accelerated. But one thing we can't forget is that fungus gave us penicillin.
Mm-hmm.
Fungus gives us a wide variety of antibiotics because out in nature, fungal cells are competing with bacterial cells and they fight one another. So they make antibiotics to kill one another, which we clever humans come along and try to harvest so that we can develop antifungals and antibiotics respectively.
Yeah.
So yeah, there's a lot of great potential in fungi. So it's not all cordyceps.
They also throw in antiviral and anti-cancer treatment. So it sounds like they fight everything, possibly.
So you're saying that there's this war between bacteria and fungus, and maybe a chosen one will come forward from one side or the other to save us all. Well, we really put a lot of fun in fungus today, and I'm sure some of you are still a little bit concerned about the idea of cordyceps catastrophes just happening all over the place. But our last story should put you a little bit at ease. Recently, a team at the Leibniz Institute for Natural Product Research found that a strain of bacteria from the genus Pseudomonas produces a substance so good at killing off fungus that they turned to John Wick himself when coming up with the name. That's right, we're talking about Keanumycin. The Keanumycin has been proven effective against several resistant fungi on plants, and now research are looking at potential uses in humans. And now is when we petition Naughty Dog, HBO, and anyone else who will listen to us to include Keanumycin and accompanying Keanu Reeves cameos in all future instances of the Last of Us franchise. We don't even need those pesky fireflies anymore. No spoilers here. So what do we think about Keanumycin, and do they know Kung Fu? I'll probably cut that part out. That was blatant spoilery.
No, you can't cut out the part about the Kung Fu.
Yeah.
It's not the end of The Last of Us. It's only the end of season 1. There will be season 2.
They might not pick it up. How well did it really do? It's just like the entire world was talking about it at one time.
No.
Everyone's following it.
They renewed it.
No, I know. They renewed it in like episode 3, right?
Right. Yeah, everyone was like, oh, that episode 3 was amazing. All right,
yeah.
Again. Yep.
So,
because it was amazing, right?
Yep.
I mean, you got Nick Offerman and Pedro Pascal in the same scene. What are we doing here?
So trifecta right there.
I have to say, this is totally like not working in service of the podcast, but the writing in the show has been incredible.
Yeah.
Right? I mean, I can't think of a single other TV program I have ever watched where you can be introduced to a character in the opening scene of an episode, and that character dies in the last scene of that episode, and yet you have lived their entire life with them, you feel like, and you care about them so much, right? And it happens not just in that third episode, right? It's several of those episodes.
There's a lot, yeah.
I feel like I got stand up for gamers around the world. A lot of the best lines are coming like one for one from the video game. There's a lot of cool supercuts you can look at on YouTube where they're just putting the scenes right next to each other. But I think what Jason is talking about is like the cinematographers are doing the best work at creating these story arcs within a single episode.
Well, and the writers, like taking a character that had no words, like no lines in the game, and then a whole backstory. And then we go to the Keanu Reeves John Wick series. Like, the fight scenes are amazing.
Mm-hmm.
Probably like this fungi killing substance.
Oh, man. He could just get helicopter down in and just take out all of the clickers with his Uzis, pistols.
Was it John Wick 3 where he uses the horse?
I don't know.
I can't remember which one.
Well, let's go
Bill's
back.
looking like,
talking
what?
about?
Let's
He uses the horse. Was it the one where he used the horse?
Oh, no.
Whose horse is that?
There's like a whole extended scene with a horse as his partner in a fight scene. Like, it's incredible.
So let's extend this analogy back to Keanumycin. What would the horse be in this vector?
In Keanumycins?
Yeah.
All I want to know about Keanumycins is, are they going to be in a red pill or a blue pill?
We just did it. We're back. So let's talk about what these Keanumycin are. They're antifungal substances that bacteria are creating. So we talked about fungi giving us antibiotics. This is when the empire strikes back and biotics give us antifungals. So that's a fun thing, right? We're like these observers looking down on this history's long war, and we're just kind of like cherry picking the best parts of it to benefit ourselves. And strawberries, apparently. That was the thing they talked about a lot in the article.
It's funny you should say that, because my immediate thought is they're so efficient, they must be killing fungus like fruit ninja.
Yeah, so they talked in the article about how this could be a natural pesticide for fungal infections on plants, and then you don't have a lot of leftover stuff in the soil, so we don't have to worry about, whatever we're using for antifungal things, probably something by Monsanto, just polluting our waterways and creating some kind of negative feedback loop that kills fish. Keanu loves fish. It's known. He's got fish tanks all over the place. I don't know if that's true, but we're putting it into the atmosphere right now.
Well, we do have to be careful with antifungals. Fungal cells are a lot more like our own than, say, bacteria cells are, and viruses are completely different. So fungal cells actually have a lot of metabolic components and structures that are similar to our so-called eukaryotic cells. So whenever we devise antifungals, there's a higher probability that those medications are going to adversely affect people. And so even, whatever antifungal we mass produce, and there's been, again, because of climate change, there's been a huge push to develop more antifungals because a lot of our grains are becoming infected with fungal pathogens, and those can get into humans. And even if we kill the fungal pathogens, sometimes they have psychoactive substances that can stay in the food product. So this is a major agricultural issue. But getting back to antifungals, we have quite a few already. I already mentioned that the development of resistance is a problem. So it's really important for scientists to continue looking for new antifungals. And that's why I was so pleased and excited to read about these Keanumycins. That's an exciting prospect. But we do have to keep in mind there's still a long road ahead. Are they going to have adverse effects on people? Because a lot of the antifungals that currently exist some are too toxic to give inside of people, and they're limited to treating those dermatophytes that live on the skin that I talked about earlier. You can put them on your skin to kill, those types of fungi, but you can't ingest them internally because they're too toxic. If any scientific benefit might come from shows like The Last of Us, it might be a greater interest to study fungal cells in general because they're pretty fascinating organisms. They're ubiquitous, but very under the radar, so to speak. So we need to learn a lot more about their biology so that when they become pathogenic, we are in a better position to spot their vulnerabilities and develop medications against them.
Bill, I think you just made an argument that we don't need to worry so much about a zombie apocalypse, but because fungus is growing on our food resources, and they may include psychoactive substances, which is the origin of the werewolf myths in Middle Ages Europe, we are really living in a world where werewolves are going to be the problem, not zombies.
Werewolf apocalypse. Yes.
Did you just come up with the next HBO series concept?
It's going to be a True Blood spinoff right here.
I did. Yeah.
Love it.
I'm going to be rich.
Just make sure you get Joe Manganiello on board.
I didn't know until I read this article that John Wick Chapter 4 comes out March 24th, and I'm really excited.
See?
Like, really excited.
So, Steffi, that was your take home. Anti-fungal's on. John Wick 4. Yay.
It's coming out.
Is this viral marketing for John Wick 4?
I mean, it's brilliant if it is, because it totally worked on me. So,
man, if we can get movie studios to invest in scientific research so they can have viral marketing moments for their tentpole franchises, we'll be in a much different place. I don't know if it'd be better or worse, but it'll be different. You've come to the end of another episode, but don't worry, we got plenty more coming your way, so be sure to follow us on social media. If you want to follow me, I'm on Twitter at James_Reed3, where you can see me begging Howie Roseman to re-sign Eagles free agents. Steffi, where can everybody find you?
you can find me on Twitter at Steffi Deem and Instagram at StarShippin.
Jason, where can everybody find you?
You can find me on Twitter at OregonJM.
And Bill, tell us where we can keep up with everything what you're doing and keeping us awake at night.
I am on Twitter at WJSULLIVAN, or you can go to my author website, authorbillsullivan.com.
And make sure you check out all the work that Bill's putting up on The Conversation. There's been some great articles lately, so we'll link to those on our website too. Follow the show at CyanitePod and visit our home on the web, cyanite.com, for links to all our social media accounts, including our newly revitalized YouTube page, links to the stories we talk about and the people we talk to, and our merch. There's lots to see, and you can see it all at cyanite.com. We'll be back with another episode in 2 weeks, and until then, stay away from those spores. The Science Night Podcast is a proud member of the River Power Podcast Mill. To find out more about our shows, go to riverpower.xyz.
So my question really is, when is Joel going to take Ellie down to the to bathe in the waters, the living waters, mines of Mandalore? That's what I want to know. That's the only way to redeem himself at this point,
Do a
right?
crossover.